Hello Legacy Sabers, Marsh here. So today we're going to do an introduction to what's known as linear programming. Basically, systems of inequalities, story problems. You're going to want to have your notes out for just some quick little definitions. And then if you're not listening to me right now, not hearing my voice, you need to be listening to my voice. So please make sure, there you are. Please make sure you are listening to me with some audio today. So, what is linear programming? What I have highlighted here is what you need to write down. So, linear programming is basically the mathematical tool for being able to maximize or minimize quantity. Usually it's for profit or cost production and subject to certain constraints. So basically it's what's the largest amount of profit I can make if I have these constraints upon how much I can make. So, most of this is mathematical decisions made by management of businesses involving linear programming. So, a lot of businesses use linear programming to figure out what is the breaking point. That's what a lot of the times will call it. It was developed sometime around World War II, and then it's used in economics, manufacturing, production, planning, and also some business management. So, here is a problem that it looks like. So, we have a potter here, and he wants to make and sell serving bowls and plates. Here's the information that we know. A bowl uses 5 pounds of clay. A plate uses 4 pounds of clay. The potter has only 40 pounds of clay, and he wants to make at least 4 bowls using this clay. So if we designate X for the number of bowls and Y for the number of plates, what we now have for constraints are, well, constraints is just a fancy word for limitations or restrictions. So, one restraint he has is he can only have so many pounds of clay. So, we know that whatever he uses for his bowls plus whatever he uses for his plates has to be less than 40 pounds of clay. It can be also equal to 40 pounds, but it can't be above 40, right? So, we made a constraint of 5x plus 4y. It needs to be less than or equal to 40. Another constraint, he said, he needs to have at least 4 bowls right here, right? So, X needs to be greater than 4 because he wants to make at least 4 bowls. At least, so that means at the very minimum, he wants 4 bowls. Then, we also cannot make negative plates. So, Y needs to be greater than or equal to 0. That's another thing to keep in mind. You can never be less than 0 because we can't have negative things. We can make 0 of things, but we just can't have negative things. So then, with these equations or inequalities, we're going to create a graph with a feasible region. So basically, we're going to make a system of inequalities using these constraints. So first, I'm going to graph up the equation 5x plus 4y is less than or equal to 40. I'm then going to graph x is greater than 4 and y is greater than 0. Notice, guys, I'm going to shade in where they would all intersect. So the feasible region is where all possible solution choices for a particular problem are. Basically, it's the intersection where all the colors would intersect because the greater than, the yellow would intersect right out down here, right? This would be my yellow color. My red would be up here, right? All up here. And the black line would have to be over here. So notice how right here, my triangle right there, that is where all of the colors are intersecting. So what we're going to do is we're going to use those points to figure out his highest profit. So really, what the question is asking is, how can this potter maximize his profit? What if the profit for a clay bowl is $35 and the profit for a clay plate is $30? So our equation would be for profit is 35x clay bowls plus 30y. Now, how are we going to use the graph that we just found to find his highest profit? Well, there's something called the corner point principle. What this means is that each point that's a corner to our feasible region will satisfy the constraint equation. But you want to know which one is going to be the highest profit amount. So basically what we're going to do is test the corner points. So I have a corner point of 4, 0. I have a corner point of 8, 0. And a corner point of 4, 5. 3 corner points. So I'm going to take that and plug it into my profit equation. So the first corner point we had was 4, 0. So I'm going to plug 4, 0 into my thing, and I get $140 for profit. Let's see if there's a better and higher profit here. If I plug in 8, 0, I get $280. Notice, double. This is not a good corner point. 4, 0 is not a good corner point. What about 4, 5? Notice that's $290. More money. Again, 8, 0 is not a good corner point. So, what is the best thing? Corner point 4, 5 is the optimal point. We get the most profit. We maximize my potter's profit. So, therefore, our potter must maximize profit by producing 4 clay bowls and 5 clay plates. That is the best way for him to make the most money when he sells his pottery. Here are the steps then for doing the linear programming. You need to read the problem. You need to make sure dissect it. Maybe underline a couple of informational steps. Then you're going to set up your constraints, the inequalities that we set up. You're going to write the profit or the cost formula, because sometimes this is also for minimizing cost. You're going to graph the inequalities, find some feasible regions, and then also use the corner point principle to find your max or your min. Now, these problems are considerably long, and they do take a little bit of time. So we will look at an entire problem together next class period. But until then, that's the end of this video. See you later, Sabers.